Hey y'all, it's me, Miss B, and today we are graphing or beginning to graph parent functions of exponential equations. So we're going to transform parent equations a little bit, but we'll get to that in just a second. So we're going to use a lot of stuff we've actually used before, kind of the logic of graphing and transformation. So if you remember, with the x values, which will be your values up here, you are going to do the opposite. So you're going to add h, which if it's being subtracted, you add it. If it's being added, you subtract it. And then if x is negative, then you want to change the sign on the values. The other thing is our y values. So that's going to be our a and k. We're first going to multiply by a, and then we'll add or subtract k. And then finally, y equals k is going to give us our horizontal asymptote. All right, and then the parent graph is always generated by the number with the exponent. So that's this number right here. It kind of decides the way that the function is going to move, and we kind of experimented with that with the Desmos activity. All right, so here's our first example. First, we want to identify the parent graph, then describe what you do to the x values and y values, and then you want to identify the horizontal asymptote, domain, and range. So basically, we're doing everything we need to do to graph, but we're not going to graph today. So first, identify the parent graph. Basically, what we need to look at is we want to look at our base, and then our exponent will always be x for our parent function. So we'll just call it g of x, or f of x, I guess. And we'll that's going to be our 4 to the x. So our bases will always match up like that. All right, and so then to kind of get an idea of what that will look like, I'm just going to say x and y. I'm going to pick some numbers like -2, 0, and 2. So if I have 4 to the -2, that's the same thing as 1 over 4 squared, which is 16. 0, so 4 to the 0 is 1, and then 4 squared is 16. So I guess I should kind of have another column here. So this is 16, 1, or 1/16, 1 and 16. Okay, so then what I needed to do is describe what happens to our values when with our new function. So I'm just going to write that in green. So our x values, what's going to happen to them based on this -2 up here is they are going to be shifted. If it's -2, it's going to go right 2. So our x values, we're going to go right 2. And then our y values are going to go up 3. So we go right 2 and up 3. So then I'm just going to make my function h of x. I'm actually going to move this up. I was trying to erase that graph because we're not graphing right now, but it's not going well for me. All right, now that that's out of our way. Oh, never mind. Okay, so then I'm gonna go ahead and make our parent graph here, or our new graph. So this is gonna be our x and y, and this is gonna be our h of x function. But we don't really have to calculate it. So all we're gonna do is for our x value, since we're going right to, we're gonna add 2, so -2 plus 2 gives us 0. 0 plus 2 gives us 2, and 2 plus 2 gives us 4. Then for these values, we have, this should be 1/16. For these values, we're going to add 3 to them, so we get 3 and 1/16. 1 plus 3 is 4, and 16 plus 3 is 19. So we're just adding 3 to these values over here. All right, so this is our new table that we can graph our functions. Okay, and then finally we do want to identify the horizontal asymptote, the domain, and the range. So our horizontal asymptote is y equals k, so that is going to be y equals 3, that value right there. Then our domain is going to, let's start with our range. Our range is going to go from that asymptote up to infinity, since it's positive, since we have a positive x value. Or I guess positive b value. Okay, and then our domain is just going to be negative infinity to infinity. There's nothing we can't plug in. All right, let's do another problem, clean it up a little bit. Oh. Goodness. All right, here we go. So, all right. So first, we want to talk about our parent function. Parent function is going to be 2, we'll just call it f of x again. F of x is equal to 2 to the x. Nothing around it. Then we'll talk about what happens with our, I'll go ahead and write out what this graph looks like. So we have our x, our y, -2, 0, 2. I use the same values every time, but it doesn't really matter what you use. So we get 1/4, 1 and 4. Then we have our x and y change. So x, because of this x right here, nothing's going to happen. And then our y values, we have a negative here and a -3 here. So it's going to get multiplied by -1. That's going to cause a reflection. And then we're going to subtract 3. So we can go, which is going to make us go down 3 on our graph. Okay, and so our function will look, just kind of talk about these values. So our x, y values are, nothing's happening, but for these we're multiplying by -1. I guess I can write that a little bit differently, just to save a little space. So multiplying by -1. And then also subtracting 3. So our x values stay the same, but our y values are going to be, let's see, -3 3 1/4, -4, and -7. Our horizontal asymptote is going to be y equals -3. Make sure you write it as an equation. It is a line. Our domain is just -infinity to infinity. And then because of this negative out front here, this range is going to be from -infinity to that asymptote. All right, and I'm going to stop there. That is all for today.